Hey, so last week we had left where um, we had enemies that were shooting bullets, the collisions worked again, and I had mentioned that we were going to spend some time doing some AI for the enemies so they didn't just move on predetermined courses around. Um, the other thing that actually ended up happening is having an enemy, different kind of enemy here. So now you'll notice that these enemies, instead of going their separate ways, they actually will follow me. They actually shoot towards me as well, which was not an option on the last game either. There are some differences between these enemies. So if I get one in my way here, if I hit a bumblebee, it goes away right away, so it only has one hit point. If I shoot towards a bat, it actually should take 3 hits, weirdly, and only took 2. I'm not sure what's going on there. Um, okay, and you also notice that the bee shoots faster as well. Has a higher attack speed. So shoots faster, but dies easier. So let's take a look at some of the code that kind of made these changes happen. So we started with the artificial intelligence part, which I'm assuming, having not delved into artificial intelligence that much, this is probably about as basic as you can get. Where am I at? Entities. Okay, so I get rid of some of these. Okay, update position. What we actually had before was in the entity function, we had like speed X, speed Y, but there's really only one thing that even, or there's two things that use that. One was the enemies. They moved around the screen in predetermined courses and they bounced off the sides. The other thing that used that speed X and Y was bullets. So what they had me do on the video was kind of take out speed X and Y from the entity, and then you had to remove it from every place that you found it, except for the one place that we actually still needed it. So you'll still see a little legacy code here on the bullets, where I have speed X and speed Y passed in, but it doesn't go to the entity anymore. It's just stored in local variables, local meaning in this function itself. And then I use the speed X and Y. If I click on those, I do have it clicked. Okay. That's why that's looking like that. Damn it. Okay, I use those to update the position of the bullet still. So that code hasn't really changed, but this kind of logic, I actually took this function from the entity class or function up above and put it in for the bullet. So I took it out of the entity completely, and if we actually look at the entity here quick, okay, let's make some smaller so it's a little bit easier for me to get around. We had update position and draw, so nothing's changed there, but if we look at the update position, it's actually empty. So I have a position there, and what this pretty much does is means that this right here isn't going to break. It's going to call this function, but it's not going to do anything in particular. So I forget what the fancy name for a function that you, I don't think this necessarily forces you like Java, but you're creating a function that you want your children classes, your subclasses, to have. So what we ended up doing is we already had kind of the logic for the player. The player already overwrote the last one completely anyway. It just made its own. So that's what we do with the enemy as well. The enemy function here did not have an update position function before. In the enemy class itself, it had one from its parent, the actor, or actually the entity. But now it has one. So here's the AI itself, the artificial intelligence. Very simple. It's comparing your player position in the X and the Y and subtracting its own X position. So it's getting the difference in the X and the difference in the Y. And then if the difference in the X is greater than 0, so that means, let's say your player X is 300 and the enemy is at 100. So 300 means it's further to the right on the game, the player is, and the 100 means it's further to the left. So you would get a difference of 200, which means your enemy has to go to the right. It has to add numbers to its X. If it's less than 0, then your player is to the left compared to the enemy, so you have to subtract 3 from it. Same thing with the Y. If the difference is greater than 0, that means your enemy is lower on the screen. So you have to add numbers, in this case 3, to it to make the enemy move down. We want to remember that the top of the screen is 0, the bottom of the screen is, I think, 500 for our height. Okay. Or actually, we changed that now that the map is bigger, so it's actually bigger than 500. Okay. So that's literally all that happens for the artificial intelligence. It's really not necessarily intelligence in the typical sense. All it is comparing data and using that data to make kind of decisions in the moment instead of having a predetermined path. So wherever the player is kind of determines where that enemy is going to move. Okay. So that's the artificial intelligence part. And the other stuff that we focused mostly on in this episode 21, 20 was mostly the artificial intelligence. 21 had to do with this fact that the bullets aren't always going to be shot by the enemies at an angle of 0, so they always went to the right. Now we are going to shoot towards the player. So, where do we have that? Is it in bullet? Probably is. Not really. An enemy then. Okay. Okay, yep. Right there. Update aim. And then there's another function that we'll talk about later, this kind of on death kind of thing. So update aim, it's using that same logic, so the difference between the player X and the player Y. And then we kind of went to another place that we used some trigonometry here. So we're using the tangent 2, which is kind of the inverse tangent. So it lets you figure out an angle. So we take our difference in y, our difference in x, and we divide it by pi because it's in radians, which is another way to measure angles. And then we multiply it by 180 because each pi represents 180 degrees. So we're just converting it from radians to degrees, which are probably what you are way more familiar with than radians. Okay, so that's all we did there. We updated the aim. The aim, we already had an aim angle as part of the object. I think if we look at the actor, we'll see that we already had a self dot. That's player. That's fine. Okay. Where is actor? It's below the player. Nope. So we have aim angle right there. Okay, we set it to default of 0. Okay, we remember that the aim angle for the player was determined by, where your mouse was compared to the player, which is where that function kind of came from before. So we have special attack. It must be an enemy. There we go. Oh, difficulty with kind of walking through someone else's code is you don't necessarily have quite the memory of where everything is located because you didn't think it through yourself. You might understand how it works once you find it, but knowing where things are is a little difficult when you watch a video and kind of follow along and work on things while someone else is doing a lot of the thinking for you, to be perfectly honest. Okay, so the update aim, we had an update aim sort of for the player where it was using the mouse. Whenever you clicked, it figured out and updated the aim. Okay, so how we do it there, and then instead of shooting a bullet at the default of an aim angle of 0, it shoots it towards the player. So if the player doesn't move, it's literally a guaranteed hit as long as they're close enough. Okay. Now onto the on death here. So why we kind of are changing this stuff is because before the enemies used this HP thing, they got assigned a default HP of 10, I believe, but we never really did anything with it. Just the moment they were hit with a bullet, we removed them from the enemy list, and therefore they were dead. So this on death stuff here, if we go to the actor, we notice that on the update, I call my super update, so I don't want to, I want to do what the original update was, which was update position and draw. But then I want to do a couple other things. I want to increment my attack speed, so every frame that goes by, I get a attack counter that goes up by the attack speed. I think it was 25 meant that you could shoot a bullet, so nothing's changed there. But then here's the thing that does change. So now we're going to actually use the HP. If the HP is less than or equal to 0, you're going to call the on death function. We notice we did another one here that it's more of a placeholder than anything. So we have the self.onDeath, but we do not literally write anything in the function. There's nothing inside the curly braces. So we don't do anything, which means that our player and our enemy are going to have customized functions here. I actually don't think that they ended up being super customized that much. I think the player just starts the game over is the main difference. So we set a value, a variable that we have right here to true. It's defaulted to false, which means you don't want to remove the enemy until it's dead. So once it dies, you set that to true. And then what I do on the update is at the end, if self.toRemove, and all I say there is just self.toRemove. I'm pretty sure you could do it this way too. So if it equals true, really the only benefit to doing that is maybe if you don't know that all that the if function is doing is double checking that whatever's in the parentheses is true or it's false. So if you put a variable in here that's true or false, that's all you need to do. You don't need to verify that it's equal to anything else. I guess I would have had to do 3 equal signs, because 1 equal sign just assigns the value to something. means you're going to set the value of self.toRemove to be true, not is it true. Okay. So if it is true, you have to remove that enemy, then I'm going to delete enemy from the list and self.id. So that's how I reference the one from the list to remove. Otherwise, it would not know which one it wanted to get rid of. Okay. So that's how I handle it for the enemy. And I think the player was above enemy. Okay, so self on death for the player here. All I did is I took the code from the player function that was already there, and I took out the if function part of it. So this hasn't even changed, I just put it in a different spot. So the time survived, says that you lost, and then it calls the function start new game. So nothing's changed there, it's just in a slightly different place. Okay. What else went on? Oh, the different types of enemies. Okay, so now we had the bee and the bat, which was the original picture. Randomly generate enemy. There we go. What we did for the randomly generate a different enemy is something that we've done in other places, like for the upgrade. I think this is the exact same if function we used. If math.random is less than 0.5, I want to remember that math random only returns a number between 0 and 1. So this means if essentially the flip of a coin is heads, which is 50% of the time, you're going to generate what? The bat. The bat has 2 hit points. Okay, what's 2? And attack speed of 1, so it's going to shoot slower than the bee. If it's the other flip side of the coin in the math random function here, you're going to generate a bee. It's going to have 1 HP and it's going to have an attack speed of 3. So withstands more bullets, but attacks slower. And this one only can take 1 bullet hit, but it attacks 3 times faster. Okay, so that's pretty easy there. And this is an easy way to kind of implement a different enemy. So now instead of like me rewriting the code for every enemy that I want to have, all I have to do is change a few parameters in this enemy function. So I changed the image, I gave it a few attributes that were different, and it did it instantly. So let's see. And you could change the image by changing the image name and getting a different image, but let's change this just to demonstrate some stuff to be some super ridiculous craziness. So the bee is going to be like super beefy now. If I update this mouse here so I can. Okay, so there's a bee. They're shooting very, very fast. 1 bullet every frame, I think, is what that is. So this actually is rather tricky. And you can notice I'm like, oops, I must have died. I don't even think I killed 1 bee before I went away. So you can change those conditions, those parameters pretty easily. And I would imagine like any of your really in-depth games that you probably buy, like a RPG where they have tons of different enemies, probably have an actual like enemy database of some sort or table where they store all the different attributes for an enemy or the parameters, like if it's not the same enemy every time, like some might have a slightly higher attack speed, then they probably have some type of random function in there. Because even this, if you start getting, I don't know, 20 different enemy types, it's just gonna become cumbersome. So I imagine they have a file that kind of handles that, where if you're in a certain area or map or something like that, they're going to have an enemy list for that map, and they're going to have different probabilities that a certain enemy is going to be in a certain place, a different generation spot, who knows. This is definitely not the most complicated game, but I'd imagine that they'd have some files that kind of help out with that and keep everything organized and the links there to the images and all that kind of stuff. So otherwise, that's the main things that happen in this game. Can't wait to see what happens on the next one.